Without any further ado, let's get going. So welcome everyone. It's an enormous pleasure to welcome you all to this Anthropocene Histories seminar, one of the series that we've been running now for a couple of years. And we're delighted to have all of the speakers here that my colleague Anna Exerholter will introduce in a second. I'll just say a tiny little bit about how this session will run. So the aim of this conversation really is to think about the implications of a range of major different markers for the Anthropocene, that the Anthropocene Working Group and an enormous variety of colleagues, many of whom or several of whom are contributing to the conversation today, so we're delighted about that, have been looking at and thinking about in relation to the vote that is going on right now, or the counting perhaps that is going on right now, in relation to when the Anthropocene Working Group will recommend the point, the marker for the Anthropocene. So we'll talk about plastics, we'll talk about fly ash, and we'll talk about plutonium. We'll start with a short general introduction to the process and the idea of these markers and the way that the AWG has been carrying them out. And after each marker discussion, we will have a conversation. The presentations of each of the markers are going to be made by a range of different scientific specialists. And then after that, there will be a very brief intervention by a historian colleague raising wider questions about the historical, political implications of particular markers. We very much wanted to have this conversation before the specific, the winner, if you like, of the vote becomes clear, precisely in order to think about the different implications, historical and otherwise, of the different markers. And it's obviously a sort of design feature of this seminar that it's bringing together a variety of scientists and historians in the spirit of the AWG's work more generally, but also in order to facilitate this, what is at this point in time a very, very interdisciplinary conversation. I'll just pass over very briefly to Anna, who will introduce the sort of the first session.
Yes, thank you very much, and a very warm welcome to this exciting session. So we're actually witnessing the making of a new epoch, and as a historian, I'm always a bit jealous of the natural scientists who get to sort of define a new era. And it is my honor to begin with Simon Turner, who is, as secretary of the Anthropocene Working Group, instrumental in organizing, communicating, pushing for these decisions, and really bringing this Anthropocene epoch into like scientifically recognized reality. He's working at the Department of Geography at UCL in London, has a doctor, his dissertation was on high-resolution paleo-environmental analysis of coastal wetland sediments, and the wetlands haven't left him, or he hasn't left them. So really aquatic systems, sedimentology, and paleolimnological records, more generally speaking, lakes, lakes and pollutions are his topic. Also, he's published on air pollution and widely on Anthropocene topics and Anthropocene markers, for example, on the Anthropocene microplastic stratigraphy of Xiamen Bay in China. He is also very, very known for this political side, on doing the work that is necessary to establish this geological epoch within several communities, and has been part of the activities at the Max Planck and the Haus der Kulturen der Welt in Berlin and other places worldwide, really. We have, for every marker that is presented by a scientific expert, we have someone from the humanities side. giving the first response, but that is really only to invite you to come up with your own comments or interests to open up the discussion. And the first discussant for the plastic marker will be Adam Wickberg, and he's at the moment postdoctoral fellow at the Max Planck Institute in Berlin, where the Department 1 is notorious for Anthropocene topics. He received his PhD from Stockholm University and has written on pellucid paper, poetry, and bureaucratic media in early modern Spain. But within the community of environmental humanities, he's really widely known for discussing data practices and the media of environments, and works in an intriguing working group that's called the Mediated Planet, claiming data for environmental SDGs. So this is our first respondent, and I open the floor for Simon.
Great, thank you, Anna. Okay, so give us a nod if you can see that. So, okay, great. So thank you. So I am the secretary of the Anthropocene Working Group, and I'm going to be talking today about what we've been doing in the last few years, which pretty much ties in with since I've been the secretary of the Anthropocene Working Group. But I'm just also going to go through sort of like who the Anthropocene Working Group is, pretty much, yeah, running through how this golden spike process sort of developed, what we've been doing, how we actually define these sort of this idea of a golden spike. I'm gonna probably have a little conversation about what the Anthropocene is, and then we'll whip around the world looking at where we're actually been doing this work, trying to identify where we can put an epoch level golden spike to define it, and then yeah, just have a look at these markers. So this is a pretty quick whip through of the work we've been doing. So the Anthropocene Working Group, it's not a huge group. It's 36 members of scientists, voluntary scientists. I mean, this is it sounds, I think, more grand than it is. We're a small group. There's only 22 voting members, and we are a task group of the Subcommission on Quaternary Stratigraphy, who is a subcommission of the International Commission of Stratigraphy, who work within the International Union of Geological Sciences, and so I thought I'd put a stratigraphy, because we're going to talk about stratigraphy. I thought I'd put a timeline of the Anthropocene Working Group together here, just to outline where we are and how we got to. So this is the last couple of decades. So I thought I'd start. Well, a classic starting point is with Paul Crutzen in 2000 at the International Geosphere Biosphere meeting in Mexico, when during the meeting on Earth System Sciences, he famously, this is a great story, but he decided that he exclaimed, but we no longer live in the Holocene, but in dramatic pause, we now live in the Anthropocene. And so this was quite a great, the solitary scientist exclamation idea that this is a defining thing, and we should not call it the Holocene anymore. And that was sort of taken up in the next few years by Will Steffen, who looked at rather than sort of maybe the Industrial Revolution of the starting point of the Anthropocene, was sort of looking at the sort of like how the great acceleration in the mid 20th century sort of really changed the dynamics of the Earth system sciences, and that sort of literature, I guess, fed into a subsequent meeting of the Stratigraphy Commission of the Geological Society of London, which was brought together by some of the founding members of the AWG to actually think about whether or not this great acceleration, this Earth system science change, could actually be recognized geologically. And that went ahead, and there was a book came out of there, and then a paper that came out from that group of scientists, came out in GSA today, where there was actually like consideration for geological formalization. Should we actually do this and call it a geological unit? And as a result of that, the Subcommission on Quaternary Stratigraphy invited the AWG at the time, or the group of scientists at the time, to set up a formal working group. And this is how subcommissions formalize geological time. They get small groups of scientists to look at a particular time unit or a time boundary and see whether or not we can, actually create a geological unit and define it stratigraphically, chronostratigraphically. And there's a bit of a gap there. You can see that I think that's the wilderness years of the AWG, but the idea there was there, and then how was it going to happen? And inevitably a lot of publications were sort of put together during that time. A critical thing that happened was actually the intervention of HKW, the Haus der Kultur und der Welt in Berlin. Actually, their cultural project had started a year before that, and they were very keen on incorporating the AWG's work to explore the Anthropocene. And so there was actually the first inaugural meeting, having started in 2009. 2014 was the first time members of the AWG actually met and discussed this idea. And then that led to, in 2016, some key questions, which is pretty much is why we are where we are, is that at the International Geological Congress, there was an AWG meeting in Cape Town, and the questions, should the Anthropocene be treated as a formal unit, be defined by GSSP, and should the base of the Anthropocene be the mid-20th century, was asked. Those questions were out there for discussion. In 2019, so it's interesting, it takes 3 years to get an answer geologically, which I quite like. So those questions were voted and agreed on as the official stance of the AWG. And so that's pretty much where certainly I came in, and this is also how this collaboration, this further collaboration with HKW and the Max Planck Institute sort of developed, because they were very keen to collaborate and actually fund the research that was going to be required to actually answer some of these questions. And so we've been working for the last few years on actually creating the evidence and then sort of writing up as a scientific study, but also as part of this collaboration called Evidence and Experiment. And just finally at the top there, we are actually now, the papers are published and we're actually voting. The process is nearing its final end, I guess, is when we need to define and come up with one site that hosts this golden spike. And so we're working towards about May to June when we'll actually have an answer for you. And so just in terms of like the Anthropocene, I just thought I'd just put this here. This is the Anthropocene we're working on. These right-hand graphs here, that we're looking at the Anthropocene that is an epoch that will end the Holocene on the left there, with their stages marked, which have already been assigned. We are very much talking about the Anthropocene Working Group is very much concerned with looking at this mid-20th century change. And that's as a result of its heritage from Earth system science, and looking at this great acceleration and looking for the geological evidence that defines this incredible and unprecedented scale of change that occurred in the mid-20th century. It's not disregarding the rest of the Holocene, the Holocene. This is the epoch defining work we're looking at. So if we're going to talk about markers, and we're going to talk about 3 of them this afternoon. But these are the markers. These markers, these stratigraphic markers, we use to define the Anthropocene. They are mainly known. The Anthropocene could have been defined many years ago using the same techniques, but so these are well-known techniques in fields like paleolimnology, which is a study of lake sediments, or paleoecology, trying to understand the recent environmental change. And these chronological, isotopic, geochemical, and ecological indicators are very well known. So this process wasn't starting from scratch. We knew where sites were going to be. We had contacts already made with research teams, and we had the tools and techniques ready to go to actually try and identify or sort of transfer this Earth system change into sort of geological reality. And so these are the sites we've been looking at over the last couple of years. I am actually going to go very quickly through each site, or sort of like a combination of sites. So we have a series of sites, we have a series of lake sites, estuary sites, we have a couple of coral sites. We even have an ice core from the Palmer Peninsula in the Antarctic. We have a marine core from the Baltic Sea and a marine core from Beppu Bay. And we have three lake sites and even some Viennese urban soils. And we also have a speleothem and a peat bog. And all these sedimentological successions are all, I mean, they are amazing things to investigate. I say to people, this is a dream job for anyone with an interest in modern sedimentology. These sites are really good at identifying recent environmental change and the impacts of human activity. So with no time to waste, this is the first of our lake sites. This is so I've just thought it's interesting. People say, well, what does the Anthropocene look like? So I'm going to go through a series of images of like, these are the sites we've been working on and the sort of matrices that you actually get from these sites. So this is Searsville Lake. It's on the grounds of Stanford University, and it's a reservoir, and the water body behind it is about 112 years old. And so the sedimentological evidence is from that lake filling up, and as it's filled up over a period of time, with storms and with sort of more arid events and sort of inwash, it has built up this amazing succession of sediments which you can actually date to a high resolution. The next lake site is Crawford Lake in Ontario. This site is these people here are ice coring. And so what you end up with, this is a really interesting site. It's very deep and it's not very big. It's like a bucket essentially. And these lakes are great because they actually create incredibly high resolution varved chronologies of sediments. So you can actually see sediments forming annually, seasonally, and at a high resolution. So you can actually peel it back like a book, like a diary. You can actually go back in time and actually find very time specific sedimentological evidence. We have another site, another lake site. So this is Sihai Longwan in northeast China. Again, it's a rather bucket-shaped lake, and it again creates these varves. These are classic varve lakes, and so you actually can use these to get evidence, as I said, from a very high resolution to an annual degree. We have an estuarine site. This is you might recognize this. This is the bay of southern bay of San Francisco Bay. And this is being looked at by a team from the USGS and from the University of Leicester. And it's a rather nondescript estuarine mud. But what they've been doing here is looking at the fossil evidence, looking at invasive species, as well as these sort of more traditional stratigraphic markers, looking at radioisotopes. And so they've actually developed a really nice chronology of invasive species as well as human activity coming into the site as well. This is another, well, this is a deep water site. I'm not sorry for button, I'm not sure what's happening there. But this is Beppu Bay in Japan. And we have an amazing anoxic basin, which is, that's not me doing that. This is a series of laminated anoxic sediments, which is, thank you. So this is a series of anoxic sediments, which is in the bottom of Beppu Bay, about 70 meters deep. And this is, again, these sort of amazingly subannually laminated sediments that are formed there off the shore of Japan. This is another site. This is the Baltic Sea. Again, this is a really nice illustration sedimentologically of what this looks like, what the Anthropocene looks like. And you'll see it in another graph in a minute, where this very distinct change from these Holocene laminated sediments at the base move into this darker material. And that's a very nice signature of this sort of eutrophication. The Baltic Sea famously is now much more eutrophic, has a lot more nutrients in the sea as a result of human activity. And you can see that in the sediments there. We have two coral sites, and these are probably the most glamorous of sites to work in. I'd certainly like to work on these. This is how you take a coral core. You swim down in a subaqua gear with a pneumatic drill, sometimes powered by I think it's oil or air, vegetable oil, not horrible oil, vegetable oil. It's actually powered, so you can actually take these very clean core samples And what you end up with, rather like the laminated lakes, is you end up being able to define and see these annual layers, rather like tree rings. And you can create this astonishing chronology of material that has become not just trapped by the coral polyps, but also incorporated into the coral skeletons. And so you end up with this very high resolution material going back to, I think the Flinders Reef core in the Coral Sea goes back to about the 1700s, and the Gulf of Mexico core that we've looked at goes back at least a couple of hundred years as well. So this is a really good context for looking at it, not just like sort of on a human timescale, but in a sort of like century decadal timescale of environmental change, and being able to really piece together a lot of geochemical variables which illustrate various processes. So for example, in the Gulf of Mexico core, you see a very nice nitrogen signature of increased eutrophication from the Mississippi. And so there are many things you can pull out from here. This is our ice core. This is Liz Thomas from the British Antarctic Survey, slicing up, I think it was 130 meters of Antarctic ice. And we've analysed this, her and her team have analysed this for various proxies, various stratigraphic markers, which are traditionally used on ice cores rather than sort of lake cores. And so we have, and also, you know, things like Antarctic ice cores are sort of like a traditional medium for looking at these sort of global changes. So it's really good to have this sort of very isolated Antarctic core to look at and to compare with the ones which are much nearer sort of like places of occupation around the world. This is Barbara. Barbara Fiałkowicz-Koziel is from Adam Mickiewicz University in Poland. And this was brilliant because midway through the process, we read her paper on peat cores and looking at anthropogenic markers recorded in the peat. And this is an area of Poland, of Sudeten mountain range, which is famously known as the Black Triangle, because for you know, like the last century or so, it has been swamped by atmospheric contamination as a result of the heavy industry developed, the fossil fuel based heavy industry from Czechoslovakia, Germany, and Poland. So this peat core records beautifully a very nice input, atmospheric inputs over the last 100 years at least, and you see some very nice distinct anthropogenic markers being recorded in there. This is in Vienna. This is a record of anthropogenic soils, and we thought it was a very good idea. It's critical to try and link this sort of work with archaeology as well as geology and stratigraphy. And the site here is a really interesting archaeological site where obviously Vienna is a very interesting city, has a long occupation period, but it also has a really interesting 19th, 20th century record just underneath the surface. And so this site was actually in a park, I think Park and Urban Soils, sitting underneath a proposed museum being constructed. So they were actually able to sort of excavate and sort of using archaeological techniques to look at the artifacts. So rather than sort of geochemical and isotopic things in these deposits, you can actually start pulling out recognizable archaeological artifacts and see how they relate to the sort of the chronology of the 20th century as with the other sites. And this is the smallest section. This is the speleofen. This is a stalactite which is being thinly sliced, and so that blue line there is about 5 millimeters compared to 130 meters of Antarctic ice. We have a 5 millimeter section of speleofen in Italy. And this has been worked up for many years before they became involved with this project. But speleothems are astonishing. They are like the coral reefs of caves. So they actually accumulate this, you know, through limestone, precipitating and incorporating humic acid from the overlying soils. You get these amazingly detailed annual chronologies being able to be identified. And so with scanning and electron microscopy, you can start identifying when the thickness changes a lot as a result of climate change. And you can also see how the speleofen has incorporated bomb radiocarbon. And so there is a great sequence here of seeing how the atmosphere was dramatically changed as a result of nuclear weapons testing in the 20th century. And so that is a very small section to be looking at. So we looked at 12 sites, and now what we have ended up with is enormous amount of information and data that we have published in a series of papers for a special issue in Anthropocene Review. And so all the teams have pretty much been coming up with this type of stratigraphic data that we've been using to interpret and examine the Anthropocene, the geological reality of the Anthropocene. So it's a combination of sedimentology. It's also a combination of purely anthropogenic materials that have been incorporated into these matrices. So this is the Baltic Sea, and you can see there's a series of radionuclides. There's americium, plutonium. The plutonium spike, as Andy will go through later, is really key to identify this time period. And there's a series of other things like SCPs that Neil's going to talk there in black, and in the Baltic Sea, things like DDT was a really key marker to identify this mid-20th century zone. And then we have an enormously complicated diagram here, which obviously everyone immediately looking at this is, I think I still am overwhelmed by the amount of information here. Beppu Bay, this is Beppu Bay. 99 different proxies were measured on this core to identify various changes, which is an enormous number of things to look at. And again, they've been looking at plutonium and cesium and things like, and also microplastics, so I'll come on to in a minute. This is microplastics, is right in the middle here. This is the microplastic concentration. So this is what we've been looking at. This is what we've been compiling from these 12 sites. And this is what we've been using as the evidence to try and think about whether or not we can identify this as geological reality. And this is a summary of all those 12 sites. And when you look at it, and when you look at these different proxies, this is just a summary of 4 different proxies. But when you line them up time-wise, and you look at not necessarily the maximum or the minimum, but when you look at when these significant changes in these different proxies occur, there is a very nice unifying evidence that around the mid-20th century, you see significantly rapid change occurring in things like spheroidal carbonaceous particles, which are a result of fossil fuel combustion. You see a very distinct plutonium signal. You also see changes in the radiocarbon as a result of nuclear weapons testing in the atmosphere. And you also see, some changes, things like nitrogen isotopes as a result of nitrogen inputs or eutrophication or atmospheric deposition of reactive nitrogen. So when you build up all this evidence and you see this, there is some reality, well, not some, there is reality, geological reality of this great acceleration in the mid-20th century. So all the while we've been doing the science, this sort of the standard, our normal line of work, our collaboration with Haus der Kultur und der Welt and the Max Planck Institute, last year was enormously busy with running these sort of four phases of lectures, performances and installations. So we had, the whole thing was called Evidence and Experiment, which was sort of like the umbrella idea of like combining the scientific evidence with cultural and historical perspectives being brought in, which is why this is a good thing to do this. This is very normal for what we've been doing in the last year, and it's something that which was unique, and I think it's something that should be encouraged. And this is the way forward to do this, to bring people together, not to try and unify what we think about the Anthropocene, but to talk about it from different perspectives. Both Neil and Andy contributed to this, and I think they would probably agree that it was certainly extraordinary to be doing these sort of installation art, talking with artists, talking to historians, to really expand what we think about and how we produce knowledge, not just knowledge, but also this idea of knowledge production in the Anthropocene. So please do have a look at that website, the Anthropocene curriculum. It's online, and now it's a huge amount of material to sort of work through and to investigate the Anthropocene. So just to sort of like summarize, so we have these 14 open access papers. They're online first. They're also in press. So that's the scientific work done. We also are voting on the sites. So we started in November with 9 sites. We're now down to 2 sites, and the final voting is going to be taking place in April with a public announcement in Berlin around May, June. We are being a bit secretive. Well, we are being secretive about it because the numbers of sites who are dropping out. This isn't usually in the public domain. This is usually stuff that, not many people mind too much about when the mid-Pliocene was. And so this sort of stuff can just go under the radar. It's announced and our parent commissions announce it and it's all fine. But there is enormous public interest in the Anthropocene. And so we're playing a bit of a game. We're trying to be open. We're also trying to sort of to make sure we don't annoy our parent commissions, because this is something that we've come up against, that they need to look at the scientific evidence rather than the public perception of what the Anthropocene is. Essentially, that's the line. So we will be coming up with a single site proposal in around May or June, and that will be our work. That will be our work. What we then do is then send that off to the Subcommission of Quaternary Stratigraphy, who have to vote on our proposal. And it's a very likely if that they may well go, we don't agree, and it will be sent back to us. But if by a 60% majority they ascribe to the Anthropocene as a geological reality, as an epoch, then they move it up to the International Commission of Stratigraphy, who also have to vote on a 60% majority. So at both those stages, it could fail, and all our work will be held in reserve to have another go at another time. So if it does all go correctly to plan, then we should be looking at around 2024 with a sort of like an IGS, International Geological Congress in Korea. There'll be an announcement of a conference there, and it will then move into final ratification. So even though we've done all this work and we're coming up with a pretty convincing evidence of the Anthropocene epoch, it's not over yet until at least 2 years time. So it's not just me doing all this. We're going to talk to Andy and Neil, who have been contributing to this as well, but it's an enormous amount of people, teams from all around the world. So it's 12 teams, each of them are about 10 scientists each. There's a lot of people involved with this, and we wouldn't have got anywhere near where we are without the support from the Haus der Kultur und der Welt in Berlin and the Max Planck Institute, who I must say thank you very much to. Okay, that was far too quick.
No, that's great. Should we just take let's just take a very, very short pause in case there are questions just on the general side of things, or any general questions about the process. So just to clarify, this is an obvious point, I think, to make, but it's perhaps useful to clarify it. There are multiple markers that are in play in each of the different sites, and so in voting in choosing a specific site, what colleagues on the AWG are doing is combining a set of markers at different strengths, at different levels, in order to think about, which on aggregate are the best sites is the best site to choose. That's accurate in terms of what you're doing.
Yeah, I mean, there is a reason why some sites do not have some markers being measured as a result of just the physicality of their matrix. So it's a very different thing to measure an ice core as it is a lake core. And so there's a reason why some things. So we tried to measure, obviously, like good experimentalists, we tried to measure the same thing in different matrices at the same time to really get a comparison. There's also the legacy, I guess, of like how these sites came on board, because it wasn't like we were given like funding 10 years worth of work and then say, how do you think you should do this? Come up with a hypothesis, come up with the techniques, and go out and do everything the same. There was a sort of ad hoc way that some of the teams came on board and what they had already measured, how much institutional funding they had. Sure. Like the Beppu Bay work of a 99 plus analyses compared to, say, the Searsville Lake one, which was like 20 odd. So you do see these differences as a result of sort of like how the process came about and what we are measuring. But yeah, we tried, I mean, like, you know, ideally, so this is why plutonium was a key thing, because plutonium is very useful to be able to measure in the different places to look at what should be a very uniform sort of pattern, because we know how plutonium was derived and how it was spread around, which is why it's such a unique marker.
And that's perhaps also useful to stress. I mean, so non-scientific colleagues looking at the geographical spread might infer that there's something locally contextual that's very important about the Ontario site. But actually, so far as what I understand it as a non-specialist, actually you're trying to strip out local, as it were, contaminating factors and focus on broader atmospheric global factors at that specific point. So there's a slight tension that it's easy for non-scientific readers to get in that sort of tension between the global and the local there.
Yeah, I mean, like, one of the magical things about working in lakes is that you can go to a lake and you can certainly see when people have been doing local activities, but it's also astonishing to find global signatures. And that is always the case, and sometimes the local processes dominate the depositional history, and other times the conditions are just right in a lake like Goldilocks that it can pick up a very long range atmospheric contaminants compared to, you know, more local things. So yeah, each one is uniquely different.
There's just a question in the chat. I think I know what the answer to this will be. Are the two sites confidential at the moment till after the announcement?
yeah, I did think, oh, maybe I could just tell everyone, but like what we're working on is we're releasing material to sort of like journalists and writers with an embargo until the final announcement.
Sure.
Just to make it something special as well. There's no point in having a press announcement if everyone knows it already.
No. Great. Okay. Simon, thank you. Do you want to just carry on and talk a little bit about plastics as briefly as you can, because we're running a little bit.
Sorry, John. Okay, this is much shorter because there's much less to say. Sorry, should have queued this up. Okay. Can everyone say that's, here we go. So if everyone can read that, I'm just going to be talking about what plastic as a marker for the Anthropocene, and I've used the traditional fridge magnet lettering technique here. Mainly, this was from a talk I gave before in about 2007, and I was using these markers because if you go to a freshwater site in the UK, you will always find one of these plastic letters floating in the water. So I think these are quite good markers for the Anthropocene. Okay, so plastics, as we know, are everywhere, and I think one of the things about plastics as a marker for the Anthropocene is probably they are so ubiquitous, they've almost become invisible. That it's taken a long time to think of these things as not as sort of a useful marker that we can actually use to identify the Anthropocene, rather than just this enormous amount of waste that we see day to day. So my pitch is that plastics, of course, should be a marker for the Anthropocene. They're almost perfect. They are a product of 19th, 20th century technological innovation. They're a product of fossil fuels. We shouldn't really be thinking about plastics as somehow separate from the oil and coal fossil fuel driven technology. And they exploded in their types and usage roughly around the mid-20th century, in line with the Great Acceleration. So you know, these are great markers of the work we've been doing recently. And they also sort of signify that they're out there in the environment in such high numbers because of mass production, the ideas of disposability, and also just our inability to sort of manage waste and even just ignore recycling in terms of with plastics. They are amazingly interesting. They're diverse in form and composition, which helps to identify what we're looking at and where they've come from. But as a stratigraphic thing, our understanding is very limited compared to like the quantification in ecosystems that perhaps people are more familiar with. And there are still a lot of unknowns regarding sources, transport, storage, biological uptake, and also taphonomy. And taphonomy is this idea of, like, you know, once it's produced, how does it actually get to where it's buried, and sort of and how that affects their stratigraphic usefulness. I'm rather keen on taphonomy, and we'll cover that in a minute. So they've been around for a long time, and this is what. So the main picture of this is I was just putting this together, saying I think what's really interesting about plastics as a stratigraphic marker is why it's taken so long for them to be recognized. This is on the left. There is a paper, Science, 9th August 1974. So that's that's 49 years ago that this group of scientists were out in the North Atlantic collecting plastic particles in surface waters of the Northwestern Atlantic, and they wrote about it. This is a great paper to read about microplastics. They pretty much nail the subject about where they're from, how they're moving around, and their likely end result is. And so that was in 1974. A paper there on the right from 2021 from Augusta Harbour in Sicily. The same sort of materials are still there. This is material, you know, so we know that this material is being produced. It's getting into the sea, in rivers and fresh waters, and so it's, you know, this has been known for a long time. It shouldn't be a surprise that this is being used as stratigraphic material. There's even a personal story here with Andy Cundy. He was my PhD supervisor, and when we were looking at the wetlands in Sicily in the mid-1990s, you used to find plastics like this washing around in the wetlands, and we actually recorded it in the first paper I wrote as a PhD student. We recorded it, that these numerous plastic beads were there, and so, you know, there was no big deal. Oh, it was plastic in the stratigraphy, and I still find it surprising that we you know, we could have done this years ago, which is really, I think, very interesting. So it's taken a long time for this to be realized, and by around, you know, 2014, 2015, there were people looking at plastics in sediment matrices, and this work by Patricia Corcoran in Lake Ontario, they were looking at depth. They were saying, well, this is plastic, it's floating around in the ceston, it's working, it's clearly coming from waste streams, and it's being incorporated into the stratigraphy. So this will be, you know, this is a future sort of like fossils will be, you know, plastic fossils will be incorporated. And so this was coming out, and there's other people like working in Taihu Lake in China. And so it was becoming very obvious that, you know, plastics was going to be one of these things to define, you know, to be used as an Anthropocene stratigraphic indicator. Now, this paper here this is 2016, this is the Anthropocene Working Group at the time, who put this paper together to actually to suggest exactly what I'm saying, that their use can be a stratigraphic indicator of the Anthropocene. So this came out, and we were thinking, well, we really should do something about this, because in this paper, it just outlines what I've just been going through, that plastic waste in the environment is not a modern phenomenon. There's no changes in plastic production and types. So these are really interesting things to look at over time. So we also have material, and, you know, and so what I'm getting to is all this work, we were sort of thinking, well, you know, we really should do this. No one had actually done this. This is theoretical. No one had actually thought about actually doing this using sort of normal stratigraphic techniques, using those sort of anthropogenic markers of radionuclides, and actually combining this sort of historical work and this known production changes like this. So people knew that plastic had increased in production, diversified in composition, and we knew it was getting into sort of wildlife and humans, and there was more concern was building through the 1990s into the 2000s. So, and there was an idea, well, let's call it the plasticine. And of course, it sounds absolutely obvious, really, to do it. So we really thought we'd better do a study. So I'm just going to go, this is why I said it was like a personal story. We decided to try and do this. We thought we'd better try and do this before anyone else did it. So we went up to a lake in North London, in Hampstead Park, and we ran through what we thought was a pretty good methodology to separate microplastics from lake sediments and try and create an Anthropocene stratigraphy. Again, there was no funding for this. It was done in the spare time, and we had to ask people to actually process the samples. But what we ended up with was this. This is a Anthropocene stratigraphy of plastics. In black is probably the easiest one to look at. This is the sort of the total microplastics we found in the sediment. And what we saw, pretty loosely, I mean, again, this was the first study we'd actually tried to do this, was actually, you do see this, there is a broad increase of microplastics in sediments from sort of the mid-20th century up to the present day. And that ties in quite nicely with these other indicators that have been used to look at the Anthropocene, like the SCPs that Neil will be talking about in a minute. So it works, plastics are an Anthropocene indicator. And so we published that. We sent it off in 2017, and we realized no one else had done it. And we were like, no one else had done this. So we were thinking, oh my God, we've done this. The first people to do this. We've actually documented it. We can show it actually works. And then it got published in February 2019, just in time, because in September 2019, a far better study off the coast of California, Santa Barbara Basin, actually did a much bigger, sort of better funded project, but they found pretty much the same thing. And so the accumulation of microplastics in the Santa Barbara Basin pretty much aligns with world plastic production and sort of the deposition rates, as you would expect, as a result of very much like other contaminant indicators in the mid-20th century. And since 2019, more and more results have come out, sort of, justifying, reasoning why microplastics are really good indicators of this sort of great acceleration, and also sort of like and also being able to detect things like waste production and management strategies to deal with that. But there's this overall idea and overall sort of evidence that microplastics and plastics themselves, in stratigraphic context, can actually be used to indicate and mark the Anthropocene. And this is just a result from Beppu Bay. The result there is quite a detailed graph, but what you see is virtually no plastics obviously occurring in 1940, and with industrialization in Beppu Bay and in Japan, you see this increase in abundance and accumulation rate of plastics, and you also see some really nice changes in different composition as a result of change in technological innovations. Just very briefly, one of the hardest things about plastics is they are very durable, and that's a good thing for us, because it means plastics are very robust, but it does create some problems with exactly what are we measuring in sediments, because they hang around for a long time. So there's not an immediate, obviously some plastics will go from the factory straight into a depositional archive, but many other plastics hang around, as we've seen in like the Great Garbage Patch circulating in the oceans. This material can hang around for a long time, so it can go in and out of different stratigraphic contexts before it finally gets to be buried. It's very hard to accurately date plastics per se. And so in the end, there are, I'm trying to think of a big enough number, but there are millions, thousands of billions of particles of plastics swimming around and being incorporated, and have been incorporated into sort of sedimentary contexts since they were invented, and they are largely still there. And it's realistic, it's relatively straightforward now to create these sort of Anthropocene histories of plastic deposition, but it is not straightforward. the improvements in polymer detection required to do this is improving. We've still got a long way to go, I think. It's massively improved in the last 5 to 10 years. And until we get these techniques really refined, it's going to be very difficult to sort of really quantify the flux of sort of plastics into these sort of depositional contexts, and also then to relate it to true sort of like historical documentary evidence of things like things like plastic use, and also sort of like waste management. There we go.
Super. Thank you. Adam, I'll just hand straight over to you.
Yeah, thank you, John, and thank you, Simon, for this fantastic presentation. I might be repeating some of the things that Simon has said. It's hard to come after someone who has just presented so much interesting knowledge from the beginning, but I'll try to make a original addition to the discussion. But basically, I was asked to talk about this from a historical and political perspective, and I will just echo what Simon said, that it's plastic seems to be so ubiquitous that it's not been recognized. The same is true, I think, for history and cultural production. It's only very recently, really, that people have started to consider plastic as a topic worthy of consideration. There are more art exhibitions, more books being produced now, but that's only last 4 or 5 years, I think. There are a few exceptions, of course, going maybe 10 years back, but so in this context, I think that I would like to think of plastics, especially in relation to developing a Anthropocene history, which has yet to be written, in which various aspects and dimensions of world history since the post-war era need to be revised and rewritten in light of the reality of the Anthropocene. A part of the challenge to do so, of course, is to consider the both spatial and temporal entanglements of matters across human and non-human life worlds. Modern history, as everyone here probably know, was built on the idea of a separation between human and natural history, a distinction that do not only collapse, as Dipesh Chakrabarty suggested about a decade and a half ago, but also need to be integrated so that historical facts of human societies and that of the Earth system and its myriad inhabitants can be understood in all their complexity together. And in this context, then plastics stand out as an ideal topic for Anthropocene history. And as Simon said, a perfect marker for the Anthropocene. I very much agree with this from a historical perspective. It's hard to imagine a better suited candidate from its invention a little more than a century ago as bakelite, the first synthetic polymer created by Leo Baekeland. Plastics has had a rapid rise to become perhaps the most emblematic material of 20th century consumerism societies in developed countries. So from the shining surface of Tupperware in imagery of the American dream since the 1950s to the Lego toys that populate many children's rooms worldwide, and the packaging of a lot of the food humans consume, plastic is really everywhere. And it's also worth noticing that it first emerged largely to replace the often colonial materials that were becoming too expensive and difficult to get, such as ivory and silk. Plastic emerged as something that was cheap and readily available for the burgeoning commodity society that would emerge in full force after the Second World War. And of course, there's this very strong synchronicity to the rise of plastic and the Great Acceleration, which illustrate many of the changes associated with the Anthropocene. I won't run the numbers. I think Simon had some of the numbers, but you see that there's maybe we could just note that there's an average growth rate of plastic production with 8.5% per year since 1950. And there's an expected the expected production in recent estimates about 600 million metric tons by the middle of this century. So there's no end in sight of plastic production, although we are very aware of how hazardous and problematic it is, and everyone agrees that we should phase it out. We are not really doing that, only on a symbolic level, I would argue, as in prohibiting straws and maybe bags, but at the bulk of plastic production is still very strong. And we could discuss why that is. Why is it not changing? I don't know how I'm doing with time. I was asked to speak for 5 minutes. John, I go on. Stop me if I go too long.
Sure.
But as the market of the Anthropocene, the symbolic value of plastics is extremely strong. In the production end of its cycle, as you know, plastic is part of the petrochemical industry, and it's produced from oil, refined into naphtha or from natural gas, thus representing a substantial contribution to the increase of carbon dioxide to the Earth's atmosphere already in its production. And on the other hand, on the other end, we have the plastic waste and pollution that has been on the political agenda for decades. And we can also note that the distribution of consumption is uneven. So the yearly per capita consumption continues to be very high in the global north at around 80 kilos per year, with a considerable smaller amount in the global south, about 5 to 10 kilos, showing that the trajectory follows that of the carbon dioxide emissions and other indicators of the great acceleration, as shown in the updated graph from 2015. That is, OECD countries have the bulk of the output here. So by being ubiquitous, readily available, readily moldable into the needs of modern man, plastic created the conditions for global trade and consumerism, while these systems themselves became reliant on plastics for packaging and other aspects of logistics and infrastructure. And all of this, of course, made possible by the cheapness and versatility of plastics. So the speed and reach of global capitalism with unending economic growth, I think, relies in no small part on plastics, which also explains why global plastic waste is expected to triple by 2060, according to this recent study by OECD. So all of the qualities from a cultural, historical, political perspective that we can see in plastic makes it a perfect marker for the Anthropocene, not in stratigraphic terms, because I'm not here to talk about that, but in historical and political and cultural terms. Perhaps, and that's something we could discuss, it might be too symbolic at this point. I think everyone agrees that plastic is a villain, everyone wants it away, so it might also risk hiding the more complex and acute conflicts of the Anthropocene. I will end with that. Thank you.
Super, thank you. Let me open it out for wider questions on, you know, Adam has very elegantly sort of unpicked the political, cultural implications of plastics, and Simon's, you know, sketched in what it means concretely from a marker point of view. But let me just open it up for questions more generally. Maybe I'll just start by asking Adam to if you want to expand a little bit on this idea that it's too symbolic, it's too what you meant by that, and then Julia and then Jenny.
Yeah, sure. Yeah, that's an idea I had running up to this seminar, thinking about it. That as Simon was expressing, I felt like this is such a great marker. It's I mean, I'm much newer in the game to thinking about plastics than Simon is, but when you consider the evidence, when you look at it from all of these stratigraphic and cultural historical terms, it's just perfect. It's a perfect fit. But then again, it's been on the agenda for a long time, and everyone, I think, worldwide agrees that it's very problematic, and yet we don't change the production of it. So having it as a marker might be too easy to agree on, something that politicians and actors worldwide could pay lip service to, saying that, okay, plastic is this very problematic substance, this matter that we have used in the Anthropocene now. We as you know, we're trying to get rid of plastics, whereas all the other more complex and less clear-cut entanglements might be harder to come at. But I don't think that in the end, I don't think that that's serious enough an objection to make it less suitable. It's just something that I thought of, that this, I mean, you could see it in the school books, how the plastic Anthropocene, everyone understands it. It's very clear, but that's just a reflection. So I'd rather let other people come in.
Sure. Yes. I mean, it's much more tangible, as it were, than spheroidal carbonaceous particles, isn't it?
Exactly.
Julia.
Thank you. I have a question for Simon about his comment that plastics are durable, and yet they go in and out of different stratigraphic contexts and are therefore very difficult to measure. Could you say a little bit about that comparatively? What is it that, is it just that people have had less experience measuring plastics, or is it something about plastic itself that makes it more likely to get into different stratigraphical contexts than other potential markers? Thanks.
So it's just really interesting. So this is taphonomy. This is how fossils, you know, like how you make a fossil and how it gets preserved in a stratigraphic context, and whether or not you know, what that fossil tells you about, you know, its life, and also it tells you something about how it was buried. And with plastics, I don't know if you see it in the news. Maybe it's just for newspapers I read, but you know, you will always find someone saying, "I found a crisp packet or a plastic bottle, and it's from 1974, and it's just come out of a sand dune. I found it on holiday," and it gets a photo in the newspaper, and you just think, well, that is really interesting because that and obviously the photo always shows how well preserved it is, and so you have this material which is, you know, was used once potentially in 1974. And it's now back into the waste stream, and it's, you know, and it's been incorporated into waste, which is modern, you know, contemporary. But all this, so there's this. I think haven't quite understood it yet, but just how much of this stuff is just swashing around. It hasn't been buried yet, and I think that's why it became suddenly very visible recently, because it just hit a threshold of visibility. I think it was also a reason in terms of its production and how waste was being managed globally. But it's also this stuff has just been accumulating for years, and so I think that's one of its drawbacks as a stratigraphic marker is its onset. I mean, we talk, you know, stratigraphically, what's really useful is when it first appears, and that is really useful. But as soon as we go into after the onset, this stuff is being deposited in soils. You know, in the UK, all these fibres were taken from sewage farms where they were trapped and then put back onto agricultural fields. And so you have microplastics which have been used, created, and they've been around the system a few times. I don't think we've grasped how complex material, once it enters these sort of environmental streams, just how complicated a picture this material has done. And I think it's the same for other contaminants. I think that one of the good things about plastics is they are visible, which helps because they're not this idiosyncratic sort of nebulous sort of contaminant thing. They are things that people see. So they are in that sense very useful in terms of illustrating the
Great. Thanks. Jenny and then Amanda, and then we should move on to fly ash.
Hi, thanks. Simon, you mentioned in your initial introduction to the overall AWG work that it's not a popularity contest. This is not a public vote for which marker wins. But then at the same time, in your introducing of the plastics as a potential marker, you kind of showed how, from a disciplinary perspective, everyone was aware that they were there, but no one was interested in them, except now they're part of maybe a wider public narrative around plastics. And I wondered if you would reflect on that a bit, about the relationship between your kind of disciplinary expectations and standards and you know, the popularity contest, I guess.
Wow, it is interesting. Like the popularity contest aspect is certainly interesting because by the process itself, you know, I think we're pretty much the best thing. If you're doing science, it's a really good idea to take on board evidence from as many things as possible. If you're going to try and define something, then you really should try and incorporate as much evidence as you can. But the actual GSSP process, which, you know, is a very standard chronostratigraphic framework to work within. So we are playing within these sort of very standard rules. But when, you know, it's very reductionist. It's extraordinary that we're trying to represent a significant global geological epoch representing humanity with a golden spike in one spot. And so the very nature of a contest to try and define something does seem a bit odd. But this is very standard practice in chronostratigraphy. But you know, like the one site that represents the end of the Cretaceous and the start of the Paleogene can be found in Egypt, even though the asteroid hit the Yucatan or what has become that. So you have these, you know, you have this. It's a very odd process to be in, to try and incorporate global humanity into sort of a stratigraphic thing. So disciplinary, it's interesting because we're using tools, say, from one discipline, from chronostratigraphy, which is a very, not arcane, but it's a very, you know, it's a part of geology that some people get very much into, but you know, other people can, you know, it's not really part of their discipline. So we're using this discipline to sort of investigate something which is far outside of its disciplinary framework. Yeah, so it is. So I don't know if that answers it or not, but it is very interesting to be in this situation where we are playing with disciplines as well.
Yeah, well, arguably, I guess stratigraphy can never have been under such pressure now, except when it was involved in debates about, you know, the historicity of the Bible. You know, do
you know, I haven't even thought about that. We should bring the Bible. You're right, John.
But you know, in a sense, it's precisely the political sensitivity around, you know, what you've just articulated so nicely. It's the discipline is being asked to bear a very heavy burden in that respect, and and that is why the concept of the Anthropocene has proved so of such interest outside of geology and stratigraphy, etc., etc., etc.
But I think for geologists themselves, I think it's a really interesting question. It might be a question that might have been best answered in a pub or in a, you know, like where would you define the Anthropocene? You know, like, you know, and that's what really attracted me to this question. It's like, if we were going to do it, where would we do it? And you think, well, there's, you know, it's a really interesting geological question to try and answer as well.
Amanda, very briefly, and then we should move on.
Yes, I thought that was a really interesting observation that you just made, both of you, about the which disciplines are bearing the brunt, and I hope that this seminar can push historians a bit more towards sharing some of the burdens of communicating on these issues. What I was going to say, and I'm sorry I wasn't here at the beginning, so maybe this has already been touched on. We've just been talking about the way that plastics are a useful way of communicating because everyone's very sensitive to them. I have found raising the question of just the sheer ubiquity of the consequences of nuclear testing globally is really shocking to audiences because people didn't know. I've been using the Kate Brown book because I'm not an expert on this, and it has just this scary, overwhelming bit at the end where she talks about the sheer number of nuclear weapons that have actually been set off, and I'm sure we're all familiar with this. But in a way, because that's such new information and it touches on things that people already know about and they're interested in, it seems to me to be a really powerful political way of talking about it, as well as all the other things that it is. That's more of an observation than a question, but I just thought it was worth throwing in that if it hadn't already been said.
You should brace yourself for Andy's presentation, because we will no doubt be going over that exact evidence of just how astonishing in the mid-20th century people thought it was a great idea to detonate nuclear weapons in the atmosphere, and here we are.
In that spirit, let's move on to fly ash. Anna, do you want to just briefly introduce Neil and Jenny?
Yes. Neil Rose is Professor of Environmental Pollution and Paleolimnology, also at University College London at the moment. He has been working on fly ash really since 1991, as far as I can gather, because his dissertation on fly ash particles and lake sediments, extraction, characterization, and distribution is already very pertinent to the topic in geography. But I think something must have happened over time, because this research that followed fly ash through all kinds of continents, and it's really impressive to see where he did experimental work on our whole globe. Starting in the Antarctica, by the way, but something must have happened with the the onset of the Anthropocene Working Group, of which he is a member as well. And this concept of the Anthropocene, of course, is sort of like integrating the fly ash topic, I think, in a new way. There are key articles, 2015's periodical carbonaceous fly ash particles proven in various sites, and also he's an expert in paleotoxicology. I will be very brief, because in the end, I think these conversations with the audience are much more important, and I encourage everyone to sort of look up this important work. And we have the respondent, Jenny Bulstrode, lecturer in history of science and technology at UCL as well. Her PhD is from Cambridge, The Eye of the Needle, Magnetic Survey, and the Compass of Capital in the Age of Revolution and Reform. And here you can also already see that she's a good historian of physics, and also takes adventurous paths, so a bit of the equivalent of the Antarctica survey. She includes not only material from Jamaica, but is also working with the concepts of perspectivism and cannibalism, and doesn't only apply that to the global south, but actually to Faraday and Fermi. And I can only strongly recommend this strong conceptual work that she does. And she will be our first respondent on fly ash. Now, please, Neil Rose, you have the stage.
Thank you very much, Anna. Thank you for reminding me how long ago my PhD was. Let me see if I can share my screen. Okay, can you all see that? Yeah, okay, brilliant. Thank you. Yes, so thank you for the invitation to speak about fly ash particles this afternoon. I hope to perhaps try and change John's mind about how about them. They're hopefully they're not quite so as dull as the plastics, but we'll see how far we go along that path. But anyway, so yeah, so this is what you're seeing there is a spheroidal carbonaceous particle, and that's what I'm going to be talking about today. So I'm aware that most of you will not know what SCPs are. These spheroidal carbonaceous particles are. This is what they look like under the scanning electron microscope there on the left, but also sort of under the light microscope, which is where we would normally see them when we're doing our work as on the right-hand side there. And these are only produced by the incomplete combustion of coal series and oil fuels. So in that sense, they are a wonderful marker of fossil fuel combustion. They have no natural sources, and their morphologies are very distinct too. So we don't really confuse them with other things when we see them in natural archives such as lake sediments, marine sediments, and as a result of this GSSP project, of course, now sort of peat cores, marine cores, ice cores, and so on. So in my view, they're a really good marker. And they're part of this, why is that not moving down? And so SCPs form part of this thing that's known as the black carbon continuum, which is where we have, as a black carbon itself covers a whole range of different particle types and sources, and SCPs, these spheroidal carbonaceous particles, sit at the upper end of the sort of what are known as the chars. These are the things which are left over when the burning is completed, and they're at the high temperature, smaller end of that particular continuum. On the far left-hand side there, we have the biomass burning, which tend to be at low temperatures, much larger particles, and so they don't travel so far. And on the very right-hand side here, we have these combustion condensates. So things like the soot, the sort of stuff that comes out the back of your cars, very much smaller, nanometer scale, produced at high temperatures, and which are obviously what's known as a bunch of grapes of morphology, as you can see in the bottom right-hand side there. And so these different particles have quite different morphologies, and we can identify them, separate them quite easily. So why do we think that these fly ash particles might be good markers for the Anthropocene in the mid-20th century? This is a sort of a figure that Simon showed a version of in his introduction, And you can see that this is of energy production using different fuel types. And you can see that from the middle of the 20th century there, we have a big increase in coal and oil in our power generation as a result of the increased demand for electricity in the start of the 20th century, or in the middle part of the 20th century. Sitting where I am in London, we're at the very close to the world's very first coal-fired power station just down in Holborn, which started in January 1882, which generated electricity for public use for the first time. And also, of course, down on the Thames, we have what is now the Tate Modern, the first oil-fired power station in the UK, as an oil-fired power station, which started in 1952. So we get from that sort of that middle, indicating that middle of the 20th century as a start for that. But we can actually see that this is a modeled data from 2003, looking at black carbon emissions to the atmosphere. And again, you can see as a result there of this sort of energy combustion, this big increase. This is divided up into different parts of the world. You can see this big increase from about the 1950s. So we might expect then to see something similar in our SCP record. And so the second part I want to is the scale of emission, the numbers of particles, actual physical numbers of particles that we're talking about. Simon again was talking about sort of the numbers of thousands of millions of microplastics, and the same is true of all these sort of particulate contaminants. So here, for example, just as a back of an envelope calculation, really, a single 2,000 megawatt coal-fired power station, which typically would use, and that's a very medium-sized power station. It's not an especially large one. And at a full operation for a whole day, it would typically use about 20,000 tons of pulverized coal. And from that would produce about 5,000 tons of ash, which, if we're very generous and we consider that our power station has very efficient particle emissions reduction systems in its operation, then that would result in about 1 ton of fly ash emitted to the air. But we know our fly ash is mainly inorganic ash, and about 5% of that is SCPs. And we know that about a 20 micron SCP, which is very typical, sort of a size that we would find in a sediment, is about 2 nanograms in weight. And then that 1 ton of fly ash going to the atmosphere would result in about 25 trillion SCPs in one day from that one power station. Of course, these are coming from all around the world in very many power stations. So the numbers actually being emitted to the atmosphere are really quite striking. So we might expect then to see this mid-20th century record in a lot of our sediments around the world. And this is a summary that I put together in 2015, which was a lot of my data, but also others from published records. And I know you're not going to be able to see the detail here. All you really need to know here is that this is what's known as flux, SCP fluxes. So this is the rate at which SCPs are deposited to the sediment record. And what you can see here, the red line represents 1950. And so you can see that at about that point, we see this big increase right in all these different samples around the world. The other obvious thing, I guess, from that map is that there's quite a big gaps, especially in the southern hemisphere. But since this paper was written in 2015, there have been a number of different studies now looking at tropical areas in Central America, also Southeast Asia, South Africa, and Australia, where we're starting to see some of these other patterns, similar patterns occurring. So when we consider our 12 candidate sites that Simon's already talked about, we might be quite confident that we would expect to see these fly ash particles and similar records. We might expect to see similar patterns in these different records. And here are just 8 of the records that we've analysed for SCPs in these GSSP sequences. The other 3, 2 of them are corals. Sorry, there's 8 here, so the other 4. There are 2 corals which we didn't find any SCPs in. The Vienna site, which we've received samples from but haven't looked at yet, which was these anthropogenic soils, and then the speleothem, where we wouldn't expect to find any SCPs in that record. So these are the remaining 8. And again, the red line across the middle there is 1950. You can see that the Baltic Sea there, the Snezhka Peat sample up in the top right, Crawford Lake, Sihai Longwan, that site in the northeast of China, all showing these very big increase from about 1950. So again, showing that very similar pattern. The Beppu Bay site that Simon mentioned, slightly delayed there, and a record more recently, perhaps in San Francisco Bay, but quite noisy as a result of that very high sediment accumulation record in Searsville. Just to mention one or two of these sites in a little bit more detail, the Palmer Ice Core was particularly exciting. This is the first time that we'd ever found SCPs in an Antarctic ice core, or anyone had found SCPs in an Antarctic ice core, which was particularly interesting. We weren't, if I'm honest, I wasn't really expecting to find any because of the very clean nature, or we expecting to be very clean nature of the site and its remoteness, of course, from any particular sites. But we looked at the chemistry of these particles, and the chemistry of the elements on the surfaces of the particles would suggest that it's from a coal origin, and then some trajectory analysis undertaken by our colleagues at the British Antarctic Survey suggests that this is from a South American or an Australian source. So that was, again, a very interesting finding. But I think what's important is to actually, as Simon's already alluded to, looking at the different patterns that we see. And I just wanted to highlight one or two of those in finishing off with my talk about these fly ash particles. And this is a record from the Baltic Sea. And this just shows the record of the fly ash particles in orange. Apologies to those of you who are sort of colorblind, perhaps. You can't perhaps see that, but all you need to be able to see is the similarity between these records. The blue is mercury, and you can see the very high resolution, but also very close relationship between mercury and these fly ash particles. And the mercury, of course, is also derived from coal burning. So we might expect there to be this very good relationship, but we also see a relationship with very many other contaminants. And as Simon has already said, that is one of the strengths of this approach we've been undertaking over the last few years. And this is the site from northeast China, Sihai-Longwan. And if you look at the bottom left-hand diagram there, you can see the SCPs on the left-hand side there. You can see the PAHs in the middle. These are polycyclic aromatic hydrocarbons, also produced from burning. The high molecular weight ones, HMW, in the middle there. The orange sort of signal are from industrial burning, so high molecular weight PAHs, so showing a very good relationship with the SCPs, as we might expect. And also perhaps similar relationships with some of these other ones, the low molecular weight ones, perhaps less so. And the soot on the right-hand side, again, coming from vehicle emissions, perhaps not such a tight relationship. But the diagram in the top right here shows the relationship between all these different contaminants on a correlation matrix, with the red values being the sort of positive relationships between these different matrices measured on these sediment cores. And you can see a vast array of different components, all showing these historical sort of correlations as we go through time. So again, showing these multiple records of contaminants, all showing an increase at about the same time, and SCPs are just one of those. I also just like to finish here, and I'm aware that we're not all in London, and apologies for this, but I'd like to finish on something that somebody raised just earlier, which was talking about the link between the global and the local. And if we're looking at these sites around the world, but we can also go anywhere nearby and find similar records. And this is just a site that Simon and I are very familiar with. We monitored it for a number of years as part of another project. This is Wake Valley Pond, just inside the M25 in Epping, just to the north of London, in Epping Forest. And we took a sediment core from there and did a number of analyses on these cores. And again, we can see this record here. So the SCPs are the dots in the middle there. This is a report that Simon wrote about 10 years ago now. And you can see the SCP record increasing at about that time. Right next to it, you can see lead isotopes, changes in lead isotopes as a result of sources of lead. To the right-hand side, the metals increasing at that time as well. And at the bottom there, we've got the industrial chemicals, so polyfluorinated biphenyls, industrial organochlorine chemicals, hexabromocyclododecanes, which are brominated flame retardants, as are the brominated diphenyl ether at the bottom. And the record that you can see there, starting from the mid-20th century, are also from this Wake Valley Pond, also showing that this record starting from the middle of the 20th century, and a whole range, again, of a whole range of these different contaminants. So we don't have to go around the world. Well, we can go to very many sites and see these records, which is, of course, just as Simon was saying, and these are an example. The one site that we're going to have to choose is just an example of what's been going on all around the world. So just to conclude then, I think SCPs, because they're directly related to a major driver of global environmental change, which is, of course, fossil fuel combustion, and they're preserved in a broad range of natural archives, I think they can be a good indicator for the Anthropocene. And some of the sequences we've been looking at are some of the highest resolution of combustion records or combustion products to date. And some of them are showing significant coincident increases with a large number of other contaminants, including things like plutonium, PCBs, DDTs, and some of those other ones I've just shown you, are also showing these many potential markers for the Anthropocene. And we can see that not just on a single site to represent the globe, but also at very many local sites too. So, and that's where I'll finish. So thank you very much.
That was super, Neil. Really, really lovely and clear. Jenny.
Thank you, Neil. So I don't want to share my desktop. I want to share my PowerPoint. Okay, it's not seeing my PowerPoint. So can anyone help me with why it can't see my PowerPoint on my desktop?
So when you try and share your screen, do you get a sort of set of options when it asks you which screen?
Yeah, and PowerPoint isn't one of them.
Is it open? Is the PowerPoint open?
Yes. Okay. That's better.
Yep.
Okay, sorry for that delay. Right, so markers are always proxies for the thing you want to know. To choose a marker is to decide what or who is represented, and I want to explore that a bit. This is a kind of limestone found in the drainage pipes of an 18th century coal mine. It's striped black and white because as the miners worked, coal dust turned the water black, and with it the chalky deposit in the pipes. When work stopped, the water ran clear and layers formed white. Regular thick white bands mark Sundays, but see one outside the pattern of the week and you know that tools were down for another reason. It is a geological record of labour, machine failure, industrial accident and strike. Mid-19th century fossil fuel lobbies used these 18th century deposits to argue that a carbon economy was part of the natural and inevitable progression of the earth. They pushed this narrative because even late in the 19th century, coal-burning steam engines required subsidies and protections to make them viable. As Anya Anim-Addo has shown in the Caribbean, the Admiralty's steam-powered fleet continued to rely on the exploitation of unfree labour decades after abolition. In 1859, John Tyndall demonstrated what we now call the greenhouse gas effect. To make the interaction of the atmosphere and heat radiation visible, Tyndall attached a thermopile to the system of laboratory analysis specified by the Admiralty's Steamship Coal Inquiry, a vast survey of global coal types led by Jamaican enslaver, geologist and policy advisor Henry de la Beach. Modelling the Earth as a system of coal burning and racial capitalism, he called its atmosphere a wondrous factory. Historically, it has been in the interests of fossil fuel lobbies to divert attention from entangled political choices to their physical consequences, and carbon was the marker they chose to do it. Tyndall was a correspondent and disciple of the economist William Stanley Jevons, who posed what he called the coal question in 1865. Why is it that the more efficient the industrialist gets at burning coal, instead of burning less, he burns more and more? Jevons's answer was part of a broader body of work that claimed extreme capitalist extraction is a natural tendency requiring enlightened governors. In 1944, his thesis was made the mandate for the World Bank and International Monetary Fund that dressed the old colonial world order in new suits and rebranded under the name development, a system of extraction first established in the 15th century. Fly ash has an advantage as a marker. It gives the answer the dominant community already want, a new phase of unprecedented development launched in the mid-20th century. But people in Jamaica haven't forgotten the 5 centuries this development economics came from. In the words of former Jamaican Prime Minister Michael Manley, you ask whose interests, I ask who set it up. The dust that fills the air in coal mines rubs into every open wound and makes permanent blue tattoos in a process Welsh miners call being mapped. Communities in Wales today remember the blue scars on their fathers' hands, and then there's this pause. It's the scars on the lungs you don't see. These portraits were commissioned to mark the closure of the last pit in Wales. Scarred faces and scarred landscapes are overlaid with the maps of their extraction and printed together in their coal dust. The artist Hilary Powell called the series Farewell Rock after the miner's term for the natural end of a coal measure, but there's something a bit unsettling about using the Welsh miner's term for a natural end, given the impact on Wales of the notorious political choice to close the pits. A choice, and here it's been naturalised. Perhaps even more striking is the phrase miners used for these tattoos, being mapped. It's something done to them. The scars on the lungs you don't see, something pathological and devastating. From the adaptation of the steam engine in the mid-18th century through fossil fuel lobbies of the mid-19th to the development of global debt in the mid-20th, these were just the latest public manifestations of a much older system of extraction and inequality that left the global majority few choices but to breathe this air knowing how it marked them. A crucial question for choosing a marker is to work out what you need to know. Do you want to measure the scars, or do you want to unpack the system that made them? That's me.
Super, thank you. Really, you got as much into 5 minutes as I would struggle to get into a whole hour. Let me open for questions. Let me just, maybe I can just start, Jenny, by asking you to unpack a little bit the implications of just that last statement. I mean, so are you, is what's implicit in that a sort of a question about what really a sort of mid-1950s marker is doing? You know.
Yeah, I mean, I'm trying to recognize that I do see that looking for a golden spike moment is a different thing for, say, marking, describing the Anthropocene in terms of kind of a popular concept. But I think that that's also something, and this kind of speaks back to my earlier kind of question about how this conversation for geologists and for fly ash specialists is also in relation to public perceptions. I mean, there's, Simon, you were emphasizing originally how important it is to show the reality of this, the geological reality. Well, there's a very strong political reason why you have to show the geological reality of this. So this whole conversation, the reason we're even having this conversation, it's formulated in this way, is not absent that political context. So while I do understand that a golden spike is a particular thing, and it has a particular form of argument, I don't think you can be naive about what you would then be participating in when you launch your golden spike and what that would mean for popular narratives. There's something quite telling about the fact that that 1950s moment is so important for independence movements and around what that might mean for responsibility, actually, about whose problem this is. Does that make sense?
Yes. I mean, it feels a bit unfair to ask Simon or Neil to necessarily comment on that, because it's a question about politics and geography and politics and and history and decolonization. But I don't know if you do want to.
I was one point I would just like to make, and I was thinking about this whilst Jenny was speaking, which was a wonderful presentation. Thank you, Jenny. But one of the, and perhaps we'll touch upon it when Andy has had his presentation, and also the response to that one, is that one of the criticisms that has been levelled at some of the markers that we've been thinking about as a marker for the Anthropocene regarding plutonium is that it's sort of glorifying is not the right word, but I mean, but just sort of this idea that using sort of nuclear weapons as a marker sort of raises this issue of sort of nuclear war being a something that we're marking down as an indicator, and therefore that's somehow a good thing. And I think my response to that is that I don't think any of these markers represent a good thing. I don't think, if we don't choose plutonium, we choose a different marker, whether it's plastics, whether it's fly ash, whatever it is. None of these are indicating good things. None of them are actually sort of representing anything that's actually a positive thing in the world, which is, of course, partly part of it. And so actually seeing the sort of images that Jenny was showing there, and sort of the physical scars, as it were, on the sort of the miners and so on, that led to the sort of the coal dust, which then led to the fly ash particle record that we then see in our archives around the world. It was actually sort of emphasizes that, I think.
Yeah, absolutely. Andy, do you want to?
Yeah, I mean, just to come in on that, I think it's a really valid point that's been raised, and I think I'd fully agree with Neil. Actually, there's been a lot of discussion on the potential use of plutonium as a marker for the Anthropocene epoch, and I think there's been people have said, well, surely it's immoral to celebrate a weapon of mass destruction, the records of a weapon of mass destruction. And I think the comeback to that really is that we're not, that there's no intention to celebrate. I think it's almost a warning from history, if you like, that the fact is that these markers, these are globally distributed, and I think this is where, in my opinion, the work that we're doing can have an impact in terms of saying, well, look, this is a really global impact that the great acceleration from the 1950s and the nuclear age actually has had on our environment. We can measure these products, as Neil has shown. The fact that we can detect spheroidal carbonaceous particles in Antarctica shows the true extent of our global footprint. And I think, as an example, just very briefly, in how that can then influence public discourse, I'd quote some of the UCL work actually that was done in the 80s and 90s on acid rain in impacts in lakes. And I think that was where the lacustrine records, the lake records, were used very effectively actually to highlight the impact that our fossil fuel emissions were having on lake acidification. And that was direct evidence actually from UCL and from other institutions of actually how that was impacting global ecosystems. So I think there's kind of a value in terms of influencing and contributing to public discourse.
Great, thank you.
Can I just very quick? I mean, it's precisely that point of the value of a warning that I'm trying to speak to, because what is, if you make the marker 1950s, regardless of what marker you use, what is your warning highlighting? Does it highlight the 1950s, or does it highlight the centuries that have created that situation in the 1950s? Do you see that's what I mean about the kind of awareness of what popular arguments, where your argument will then get taken. Anyway, sorry, I talked too much.
I'm just keeping an eye on time. If any of the speakers or contributors couldn't run over a little bit after 5, maybe they can just send me a direct message in the chat. But let's just run this conversation a little bit, because I think we'll end up being timed out, and I really don't want to overly constrain the conversation about plutonium. Jim, and then Jim Secord, and then Andrew, and then we should probably move on.
Hi, thanks. I just want to raise the question which has struck me, thinking about the relationship that Jenny raised between the public perceptions of these questions and the scientific ones. There is an issue which I think in the public realm, which is both what message is going to be sent. And I think that's a really important thing. What kind of labor, what kind of historical relations are being communicated. At the same time, there's sort of a conflicting need, which is to make sure that the procedures that are used to define the Anthropocene are as similar as possible to those that might be used to define, say, a period when there were no humans at all. Because otherwise it looks like it's a politicized decision. Now, one could argue that the main point then is to show that all these decisions are politicized, which if you look at the history of stratigraphy is to some extent pretty evidently the case. Stratigraphy was invented in Europe and spread out as a way of identifying the ways of using minerals, identifying strata across the world and so forth. So it's very much implicated in that. But on the other hand, we have these procedures to use. So it's more a comment than anything else, but I do think that it's one of the reasons why many of the people in the scientific community feel that what they're looking for is very much something that is very highly identifiable as a stratigraphic marker in quite a traditional, rather almost boring sense, because it's the boringness that might give the Anthropocene ultimately the greatest chance of scientific authority and power.
Simon, did you want to come in?
Yeah, well, I agree. I mean, it is the apolitical, is that a word? You know, like to say that this isn't a political statement. You know, I mean, we live in a political world, so whatever we do, if it doesn't happen, it's a political statement, as well as if it does. So to sort of say this isn't a political thing, then you'd be lying, because as you say, stratigraphy, you know, but who measures stratigraphy? Why do some scientific institutions do geology? Why does Imperial have a legacy of exploration for, no, of course it's a political thing. Stratigraphy is ingrained in that. So it is, but I like the idea of it. The boringness is what will see us through. And it is that sort of, if we go down the route of trying to define it as an epoch, you have to go down these very boring routes. They're not boring, I think they're fascinating, but you know what I mean, it's as Boris Johnson said the other day, them's the rules. If we want to define it as an epoch, then you have to define it following very strict instructions and procedures.
Yeah,
and that's the only way.
I think Jenny's point, which is a very powerful one, is that there will be consequences to the choice, and the empirical questions on the stratigraphy side cannot look at those consequences, or I presume none of the questions that the voting members need to answer. Encourage them to ask any of those questions. I'd assume they're all necessarily ruled out of court. But the way the politics of it will then play out may well have unintended consequences that the AWG wouldn't necessarily want to have. But no,
absolutely. So to define the GSSP site in the Antarctic would have clear implications, very different political implications than if it was underneath Vienna. It would, of course, very different questions would be asked, and then like Antarctica, is a pristine wilderness, but it's also a legacy of colonialism. So all of these things have very interesting stories behind them, but not are ignored, but they sit behind this sort of stratigraphic marker question. Every marker has a story to tell, which is uncomfortable. But is also, there's a utilitarian usefulness of these things, as we'll find out with plutonium.
Super. I suspect Andrew's question will be on this topic too, or comment.
Am I on video now? Yeah.
Yes.
Yes. Well, thanks to both of you for fantastic presentations. I mean, I think Jenny's point is really crucial in linking back the markers to raising the long colonial history which has led to these effects. But it also, and perhaps this is kind of coming back to the history of science and history, points to the rather neglected relations between the history of the technosciences, and particularly fossil fuel and petrochemical industries, and the immediate post-war period of decolonization. I mean, one might mention the 1953 coup in Iran, for example, that it points to a very neglected area of study for both of which deserves more study to investigate these relations.
Absolutely. No one's emailed me to say they really can't run on a little bit after 5. So I'm hoping we can do that and give Andy and Julia their sort of full reign. Anna, do you want to very briefly introduce them?
Yes. So Andrew Cundy, as was mentioned already, is also a member of the Anthropocene Working Group. He is chair of environmental radiochemistry at University of Southampton. Also, his dissertation topic on radionuclides predestined him on the road today, where he's also research director of the GAO, Radio Analytical Research. I think it's a consulting body, seemingly for the whole of UK or beyond. Also, he's invested in UNESCO Geohazards Committee. So someone who's like in his scientific field as a geologist, very, very much entangled in political discussions. Thank you for that. And we have Julia Adonai-Thomas, who is professor at University of Notre Dame, holds a PhD from Chicago on the politics of nature in 19th century Japan, but has contributed greatly, has published with many secretaries of the Anthropocene Working Group, has contributed on the altered earth, getting the Anthropocene right, and numerous other topics. Also, her 2014 paper on history and biology, I think, is still one of the best introductions into the field. Thank you so much for you both. And maybe we have Andrew Cundy on plutonium first.
Thank you for the kind introduction, Anna. I'm just going to hopefully share my screen. And can you see my presentation now? Mm-hmm. Okay, thank you. So thank you for the kind introduction again. It's my great pleasure to be here virtually with you all this afternoon and following in footsteps on some excellent talks and presentations. What I would like to present today is a brief discussion on locating the Anthropocene and nuclear fingerprints. So just as a word or two about my background, so I joined the Anthropocene Working Group just after 2019, actually, and our role within that at the University of Southampton and the GAU radioanalytical laboratories was really to provide plutonium data and analyses for a number of the GSSP sites, candidate sites that didn't already have plutonium data. So we were providing data across a number of sites. So in terms of the radioanalytical laboratories I represent, just to note, as Anna's pointed out, we do a lot of work with universities, with industry, but also we're a member of the International Atomic Energy Agency Almira network, which is kind of the rapid monitoring response network should a nuclear incident, accident or detonation occur anywhere around the world. So we'd be informing public health strategies in relation to those incidents. Okay, so what I'd like to consider briefly is plutonium and other nuclear fallout products as potential markers for the Great Acceleration and the base of the Anthropocene. So as Simon's already noted, they were talking initially about material proxies of the Great Acceleration, this dramatic, continuous and roughly simultaneous surge in growth rates across a large range of measures of human activity from the mid-20th century, but also recognizing the much longer history behind that. So we're talking about a trajectory rather than a single point. But many have argued that this point in around about 1950 was the point at which the bounds or the variability of the Holocene, the current geological epoch, were left behind as a result of human activity. So 1950 is really that kind of key point we're considering. And I'd like to overlay a nuclear timeline on that 1950 point. And this is a diagram modified from Colin Waters et al. 2016, which plots the aggregate number of nuclear tests against time. And so, as we've noted before, a large number of above ground atmospheric thermonuclear weapons tests were carried out, particularly in the 1950s and 1960s. And also previously to that, we have a number of test and also military detonations as well. These early tests and detonations, geologically speaking, labeled significant areas of the terrestrial environment and parts of the marine environment with nuclear fallout products, but particularly with the initiation of high-yield thermonuclear testing, H-bomb testing, which began with the Ivy Mike test at Enuitak Atoll in the Pacific Ocean in 1952. That was when really nuclear fallout shifted from being regional to effectively a global fingerprint of nuclear activities due to injection of detonator material into the stratosphere and global dispersion. And we can really see that in the upper diagram there when we look at the blue line, which is the solid blue line, which is plutonium deposition density. So this is where we see this large-scale deposition of plutonium effectively globally beginning in around 1952-53. There's a pause in the late 1950s related to a nuclear weapons testing moratorium, and then a real increase in the early 1960s relating to nuclear testing activity just before a limited test ban treaty in 1963. Okay, so arguably, the argument has been that the use of the plutonium fallout in particular from the Ivy Mike detonation and subsequent detonations as a marker of the base of the Anthropocene. So what are the key nuclear fallout products we're looking at that might generate a stratigraphic signature? Well, the specific fallout products we see following a nuclear detonation depend on the characteristics of the device detonated and the nature of the detonation. But generally we see three main groups of fallout products: fission products, which are produced by the splitting of uranium or plutonium atoms, actinides, which are produced by neutron absorption, producing heavier products like plutonium, and activation products, which are produced by neutron bombardment in surrounding material like carbon-14. These are actually already widely used dating tools in the wider earth and environmental sciences. They provide a go-to method that most environmental scientists use to get an idea of the age of modern sediments and sediment core, plus they use as water mass tracers in oceanography and in groundwater studies as well. We can also use some of the isotopes, some of the products to source fingerprint to determine the source of the fallout. And this is particularly true with plutonium, particularly looking at the ratio of plutonium-240 to plutonium-239. Effectively here, that ratio depends on the source. Okay, so weapons grade plutonium material used in thermonuclear devices has a very different signature to nuclear fuel ratios. And here we can see that very clearly in the lower graph, which is a time calibrated record in a sediment core from close to the Sellafield nuclear facility in the UK. And here we can track the history of Sellafield moving from being effectively a site for producing plutonium for the nuclear weapons program over time to becoming a nuclear reprocessing facility where these much higher ratios are as in the upper part of the core as a result of reprocessing spent nuclear fuel. So what makes an effective marker? I'm not going to say a good marker because, as we've seen, I don't think we've really got many good markers for the Anthropocene if we're looking at it from a morally good viewpoint. But what is an effective marker? Well, from a stratigraphic point of view, an effective marker should be global, persistent, easily measured, and isochronous. And by that I mean should be deposited at approximately the same time globally everywhere, as Neil has shown very eloquently for the spheroidal carbonaceous particle data that he showed earlier. So plutonium isotopes readily associate with clays and organic particles in lake, marine and other settings, and you can distinguish characteristic fallout signatures in marine and lake sediments, ice cores and other media, correlating with the diagram that I showed you earlier on, broadly correlating with the number of aggregate tests conducted in the atmosphere. So when we're considering candidate sites for the Anthropocene global stratigraphic site and point, GSSP, and we can compare that with some existing GSSPs which are marked with a golden spike, or in the case of the Piazenzian, a metal nail. Can we actually pinpoint the base of the Anthropocene using nuclear fallout products? Well, Simon's shown this diagram earlier. This relates to the different markers at a range of the GSSP candidate sites being considered by the Anthropocene Working Group. And we can see that across many of those, the closed square that marks plutonium shows an onset in around about 1950. Okay, so we're seeing that 1950 increase or 1952 increase strictly of plutonium fallout recorded in these range of sedimentary materials. Example there from Crawford Lake in this very nice barbed sequence. We can clearly see there the spheroidal carbonaceous particles concentration increasing at around about 1950, and that's matched by the plutonium 239-240 radioactivity profile within that core. The Baltic Sea example there, we can see really sharp peaks for americium-241 and plutonium in around about 1963, correlating with the year after the peak in above ground nuclear weapons testing. But also on the plutonium isotope ratios there, we can see some changes that relate to possibly to the early tests in the Pacific. As we move up the core, we're seeing an average fallout ratio. And then as we get towards the top, we're seeing some fingerprint there of the Chernobyl disaster. And also West Flower Garden Banks in the Caribbean there, one of our coral sites. Again, we're picking up these plutonium fingerprints at really, really trace levels. In this core, actually, the carbon-14 signature is much stronger, being as this is a carbonate deposit. So in terms of the use of a marker then, what about the distribution, preservation and ease of measurement of plutonium and other isotopes as global markers? Well, not all latitudes are equal and not all deposits are equal. And here we've got some data showing the global strontium-90 fallout deposition. Strontium-90 was one of the fallout products that was measured over time. There was concerns that could accumulate in human food chains. Strontium-90 accumulates in bones. So that was measured. Plutonium wasn't actually measured. We don't have a very good record of plutonium fallout over time, actually. And this is where the geological records have been used to complement that and work out where the initial fallout actually went. But here we can see very clearly in the mid latitudes, there is a fallout maximum, basically, in the northern mid latitudes. And effectively what we're seeing there is the effect of where the tests were located, the nuclear testing, but also we're seeing a result of atmospheric circulation cells as well. Also, not all deposits are equal. So some of the deposits we've looked at record a much stronger plutonium signature in terms of total radioactivity of the plutonium than others. So the becquerel is the unit we use, which is 1 atomic disintegration per second of plutonium. So Crawford Lake, lake sediment has about nearly 18 becquerels per gram of plutonium at the maximum fallout time. The coral from the Caribbean has about 0.3 becquerels per gram, and the Palmer ice core really, really trace amounts. So just as an example comparator there, the average human contains about 4,300 becquerels of naturally occurring potassium-40, so within our bodies. So gives you an idea of the scale of the fallout there. So plutonium, we believe, provides an effective marker that doesn't mobilize very much once it's deposited. In some settings it can, and carbon-14 can also have issues around providing an integrated signal rather than actually a really precise time horizon. But I think the key point is that plutonium signal from fallout is effectively global, and it can be detected using standard counting techniques in sediments, soils, corals, and ice. So some data there from the Palmer ice core that Simon's mentioned before. And there's a very large literature on this in addition to the candidate GSSP sites. Some examples there. So data collected by various groups all over the world looking at fallout records in ice, coral, sediment, etc. So to conclude, plutonium fallout has been argued to be a strong candidate to define an Anthropocene basal boundary. It's mostly absent in nature. It's got long half-lives, which provide a long-lasting signature in the geological record. It forms fixed and relatively isochronous marker in geological deposits. So we can pick this 1952 onset and 1963 maximum fallout globally. And it's present in sufficient quantities to be readily detectable. Okay, so it's estimated that around 3.5 tons of plutonium from weapons testing entered the Earth system. from the global nuclear weapons testing activities that were undertaken. That's been widely dispersed through the Earth's materials. And by the time we get an individual sample from a coral or a sediment, we're looking at ultra trace levels, less than a trillionth of a gram, but we can measure that. So the plutonium provides a high resolution record at a range of the candidate GSSP sites in combination with a wide range of other anthropogenic markers. It records the onset of thermonuclear testing in 1952 and subsequent fallout changes. And there's potential for source discrimination to individual groups of tests or input events. And I think the key point here is that there's this evidences that our nuclear activities have labelled environmental materials from poles to tropics and from the shallow to the deep sea. So there is a truly global record of these activities. Even where activities are very low, advances in new techniques like accelerated mass spectrometry mean that we can determine down to incredibly small levels. So there's a new accelerated mass spectrometry data set already been derived for the Flinders Reef coral site, again, which shows really clear reflection of global fallout within these corals over time. The latest generation of accelerated mass spectrometers capable of determining mass fluxes of individual plutonium isotopes down to 10 to the minus 17. We did some recent work on the Sellafield nuclear discharges actually and their retention in sediments around the Sellafield facility. Other work has looked at actually using plutonium-244, which is an isotope of plutonium that's naturally produced in really trace amounts, as an indicator of past supernova events in the geological record. And that's capable of detecting down to 15 atoms per centimetre squared per million years in ocean crust. So I'll leave it there. Thank you for your attention. That was a very quick run through plutonium as a marker, but I'd welcome any questions in the discussion. Thank you.
Super, thank you. It's extraordinary, that the level of granularity there. Julia.
I'm feeling a bit dizzied by our run through, and I know we are over time now. So I want to begin by saying how grateful I am for the clarity with which our scientists have spoken about the GSSP markers. I was at first thinking, Andy, that I would respond to your presentation on plutonium as a historian of Japan, and talk particularly about Japan's relationship with nuclear weapons, nuclear energy, and now is under threat of nuclear war from the continent. But I'm not going to do that. I'm going to wear my intellectual historian hat and be quite brief. So I'd like to make a distinction, and I think this is a very important distinction as an historian, between interdisciplinary work and multidisciplinary work. There's been a call, and John, I believe you used the word interdisciplinary, to have us join forces and approach the reality of the Anthropocene using the same language, the same techniques, the same understanding, and ultimately harmonize and synthesize our vocabularies and our concepts. But today's presentations have made me feel even more strongly that a multidisciplinary approach is important. And let me make clear as to what I mean, and also what Jan Zalasiewicz and Mark Williams and I met when we wrote the book, The Anthropocene, a Multidisciplinary Approach. So first, I should simply say that I am absolutely convinced by the evidence you've given us that there seems to have been a remarkable chronostratigraphic change in the mid-20th century, as far as I, as an historian, can understand such a thing. I don't feel that it's up to me to make that judgment, but my goodness, the evidence you've given us is astonishing and deeply humbling as a member of the human race. And I very much hope that ultimately it will be officially formalized as a new epoch, because I think it will help us think about it. But I don't think that that's necessary, because the work that you are doing, as Simon said, is odd, I think was the word you used, Simon. It's quite specific, this notion of marker and what it means. But what it is emblematic of is the Earth system transformation that we are facing. And for an historian, it seems to me less interesting to have a chronostratigraphic marker than to have a very secure sense of the Earth system science great acceleration that occurred in the mid-20th century and how that transforms our understanding. So marker is not a term of art in history. We don't speak of markers. We tend to use a word event. And the word event has been thought of by philosopher of history Martin Jay as having two kinds of resonances. One is approaching an event as contextualized, understandable in terms of its context, and suggesting a certain developmental continuity that will ultimately submerge its extraordinariness. The other understanding of event, and this is the really important one, I think, for us today, is the idea of an event as inaugurating a new world. And this comes from the historian of history, Claude Romero, who speaks of an experience that we can only understand in retrospect, that transforms the language that we use, the categories we operate with. And it seems to me that that notion of an extraordinary, irreducible event that has transformed our world does, in fact, explain for historians what the Anthropocene is. And whether or not the bureaucracy of stratigraphers ultimately give us an official approval of that term as a new epoch, I think the Anthropocene is here to stay as an important conceptual category for understanding the ways in which, through multidisciplinary understanding, we can come to terms with our transformed planet. So thank you all very, very much. And I'm grateful for the chance to be part of this.
Thanks so much, Julia. That was wonderful. Maybe let's, if colleagues are happy to, let's just run on. I know we're 12 minutes over, but let's just run the questions and conversation on a little bit, and I think we can also move out into broader conversations as well. Maybe just to get things going on what specifically in relation to what you just said, Julia, about markers and how one thinks about events. I mean, one of the ways in which I find it quite helpful to think about what this whole conversation about GSSPs is doing, what is it that one is marking there, is to use a term that's very, familiar to historians, to think of what it is, is being measured here as a terminus antiquem, as the latest possible date that we can say that something has occurred, versus terminus postquem, the standard historical term for talking about the earliest date you could say something happened by. So, the GSSP, whatever it turns out to be, it seems to me to work well to think of that as the latest possible date that one could say the Anthropocene has started. Colleagues can tell me on whether or not that makes sense from their stratigraphic perspective. But Julia, if one thinks about it as an event that is inaugurating something, then one's thinking about it as something that is starting a process. And so if one's thinking, but if one's thinking about the early 50s, 1950s as the point by which we can say, yes, this absolutely has started, then one's pointing backwards to a whole set of structures and political processes and industrial processes and economic processes that have now borne fruit in the Anthropocene. If one's thinking about it as inaugurating something, then one's thinking about something as starting from that point. So is how I'm thinking about it very different from how you're thinking about it? Or, I mean, I suppose maybe I'm just asking you to say a little bit more about what you mean by inauguration in that kind of a context.
What the phrase that Romero uses is to inaugurate a new world.
Okay.
And of course, we now have to be careful about new worlds. It tends to have either a good connotation or the imperialist connotation that the Americas were a new world. So in thinking about that idea of an event which transforms our values, our capacities for justice, our understanding of what's going on, I'm talking about the inauguration of a new, essentially a new intellectual world, a new way of thinking is where I'm getting this from Romero. But that harkens to the notion of a new epoch. So I think there is something unprecedented that occurred that we have to think about, which isn't, of course, to deny that things happened before this new world was inaugurated that will have shaped this new world. I don't suppose that would be a very useful way of thinking about things, although some people have now argued that the Anthropocene is in fact something like that. But what I'm trying to underscore here is that the kinds of disciplinary thinking that we have been engaged in and trained in has to be rethought. That, in fact, John, I would say this is what you're trying to do here through this seminar, by bringing us together with the scientists to underscore the fact that our disciplinary training needs to be revised.
Yeah.
And we need to come up with new ideas. So, I'm drawing here on people like Amitav Ghosh's views that in the Great Derangement, that our current intellectual environment is not sufficient. So I hope that's a bit clearer.
No, and I think the contrast you're making there, the distinction between interdisciplinary and multidisciplinary is very well taken. Simon Schaefer.
Hi, thank you very much to everyone for very illuminating and clear discussion. I'd like to go back to a point that Jenny raised in her very fine intervention, because I think it needs a little more attention. I know we're short of time. If I'm not wrong, most all the markers which characterize the Holocene, and indeed most of the Quaternary, are either climatic or magnetic. And they don't use, for perhaps rather obvious reasons, fossil markers. You have to go further back to use fossil markers. So one of the fascinating things about the group's intervention now is that the markers are neither climatic nor magnetic. On the contrary, what they propose, and this is where I think part of Jenny's intervention is really invaluable, is a reflection on responsibility. and responsibility in both senses of that term. Because the choice of a marker is, as Jenny has shown us, inevitably a choice of the agent that is responsible. And in that sense, the plutonium problem that has already been raised clearly addresses that issue of responsibility and its ambiguity, because responsibility is simultaneously about cause and it's about ethics. Plutonium can be a marker because the people who are responsible for it were not responsible. And that is a very important issue for the group to vote on, it seems to me. I mean, that's not really a question, sorry, but I just want us to have a moment to reflect on that, because I think it's very important.
John, may I come in here?
Do, yeah.
Simon, I think your point's very interesting, but I don't think that we should ask the Anthropocene Working Group to adjudicate the responsibility of actors who put plutonium in the atmosphere. Or I think this is something that historians of science, politicians, and indeed the global community need to address.
You're absolutely right. My point is that the assignation of a marker is the assignation of responsibility in the causal sense. Otherwise, it doesn't work. And
no, I don't think that's right.
Well,
but our scientists can speak to this. I think that the marker is not the cause of the Anthropocene.
Well, that's what's interesting about the choice of climate changes as markers during the Holocene. I mean, there is an interesting entanglement of the process by which the reversal of the poles or climate change of various sorts has been turned into a marker, or the disappearance or appearance of particular populations. Causation is absolutely at work there. So I'm not making a very strong point, I think, but you're absolutely right, trying to reinforce the thought that it's almost impossible to disentangle, exactly as you said, multidisciplinary and cross-disciplinary issues from an issue which, as several of our colleagues have said, puts enormous pressure on this group of geologists.
Yeah.
I mean, it really, really does. And one needs to be sensitive to that.
I think that's great, Jenny. Yes, I was going to ask you if you wanted to come back in on that. I think
yeah. So I mean, to speak to what Simon was saying, but also Julia's response, I guess, I want to push back against the distinction that's being drawn between science and history, partly because I guess as a historian of science, a lot of the time I'm teaching science students. People in my department tend to come from science backgrounds, and we've moved into history. But part of what that raises attention to is that sciences are always also historical, even if that history has a very short-term memory. They're going back over past papers, they're reviewing past traces. They are performing the same actions that historians perform. And we're very familiar in history of what happens when you define a period of study. So I teach history of modern science, and that's everything from 1800 onwards. Now that has a curious effect on the students and on what I teach, because it defines modern science at a period of European colonial domination, right? So Europeans become the bearers of modern science and everyone else loses. But there's something, you can see that something will happen, whether it has happened yet or not. When you guys decide that marker, that will decide in a popular imaginary whether, and also to some extent in your own way of thinking about it, that will decide the terms of the conversation you're having. And there is a sense of a causation in a short-term memory loss around defining the terms of the conversation that you're having, where once you say it starts at this point, this is our marker, that loses certain other causes that sit behind that over a much longer period. It's not your you haven't done that. The work you're doing is amazing, but I think it's being aware of how that gets translated, and I think that's what Simon was speaking to in that relationship between marker and causation, and it's what I was certainly trying to get across in showing the way things like that limestone deposit in the drainage of coal mines was actively used as part of an argument. The way that these material markers have been used to make these arguments around, in a sense, that short-term memory, that don't remember that maybe this wasn't the only way of doing things, that instead put it as something natural and inevitable. Sorry, I'm just repeating myself now.
Andy.
Yeah, I mean, don't worry about repeating yourself, Jen. I don't think you were, and I do find that argument, fascinating. I'm actually from my grandparents were miners, so I'm from a mining family, and it is I find that trajectory, absolutely fascinating. I think one of the things I would say is that these type of events and the argument about interdisciplinary and multidisciplinary work and the events in Berlin, I found them fascinating to have these type of conversations, and I think these conversations in themselves are really valuable, because as Simon's pointed out earlier, it's quite an unusual process. It's not something that would normally be considered in stratigraphy, and I think it's really informed the Anthropocene Working Group in terms of sort of justifying its approach, actually, and by saying, well, this is a long time period that we're looking at. We're not just saying human impact started in 1950. Obviously, that was when there was a great acceleration. This is when we're arguing that we've left the bounds of the Holocene behind. But actually, there's a whole earlier phase, dating right back to fire clearances and way back into prehistory, that have influenced this, and the politics have influenced it. I agree, and the economics. So it's something that we've had to be very, very aware of, and there's been a long discussion over whether the Anthropocene should actually be an epoch or an event, and that's been a very stratigraphic argument between various kind of archaeological and other communities. But I think from my point of view, having these discussions is really valuable, and I think I would say that the Anthropocene Working Group has really tried to and take some of these arguments on board, and I think and reflect really on our own practice, actually, in terms of our background to, are we promoting a particular marker, or are we how objective are we being, and what's our background in that. So I think it's been a really, really useful process, actually, to have these kind of discussions and these debates.
Thank you. I'll just let this run on a few minutes more, and then we'll close down. But it's a really valuable conversation. Andrew, and then Amanda, and then I think we probably should draw it to a close. Andrew.
Thanks. Yeah, very briefly, just commenting on what has just been said. I mean, it strikes me that perhaps one is not talking here either of multidisciplinarity or interdisciplinarity. But I think what Jenny and Simon have just been saying suggests a kind of, it's really a question of thinking about what kind of disturbance. Geology, the geosciences have provided a disturbance to history, introducing the importance of thinking about the history of the planet in history, but also perhaps there's a disturbance the other way around. And the question is what level of disturbance it is. What kind of disturbance is introduced by thinking about the long-term issues of responsibility and causation, which Simon and Jenny have just raised? I think that's an open question. It's not straightforward, the answer, and it doesn't destroy the scientific arguments, but it kind of raises a kind of further disturbance which needs to be addressed.
Yeah, I think that's very, very well put. Amanda.
Also, very quickly, it's reminding me a little bit of when it was generally accepted that climate change was anthropogenic in its causes, and everyone said, okay, that's what it is. And then they moved on looking at what was happening with climate change, rather than realizing that the causes were actually probably the most important thing to understand, and that they were, you know, the fact that it was caused by humans meant that we suddenly had to understand humans in a much better way, and that was not done. And I think that that's one of the reasons we're having so much trouble now. And I think this is an opportunity actually to make sure this doesn't happen. And again, I really don't think the responsibility should be thrown on the scientists for doing this. I think this is work that is in fact already happening, but so, you know, needs to be done to serve that purpose, I think, and make that point.
Yeah. Absolutely. I mean, maybe just as a final kind of comment. I mean, I think Andrew's comment in the chat about the way the markers point both backwards chronologically, but also forwards prospectively to what needs to be done in order to respond to them is well taken. I think there's a challenge in terms of how there's an enormous challenge in terms of how the markers will, how the GSS, the eventual GSSP will be received, in terms of what the sorts of stories that will be generated around that marker will be led, you know, will be used to do. And I think that's very much to the burden of Jenny's comments about, you know, how will a sort of a moment that correlates, not causation, but a moment that correlates with decolonization and that is generating all of these problems at a global level from human impacts be read politically going forward. What if 1952 thereabouts is the cutoff, will be deemed to be relevant to explaining how one got to 1952? You know, I think even if one accepts, you know, Andrew's point that they point backwards, there will be a lot of work that needs to be done in order to force people to recognise that simply looking at that point forwards is not how you're going to address the issues that arise. Even if the point is in and around the mid-50s, which is simply to say what everyone else has said far more eloquently, that there are enormous kind of pressures on stratigraphy and the scientists working on this material, that they can't possibly be allowed to bear themselves. But that's the conversation between sciences and social sciences and humanities is reconfiguring them, is disserving them, absolutely, as Andrew says. And I think it's beholden on all of us to try to work out what that means for our disciplinary settings, so to speak. And this, as so many other things that colleagues are involved in, is part of the process for trying to work out the implications of that. So thank you so much to all of the colleagues from all of the various different institutions, both for their time and labours, but also for their willingness to participate in this conversation, which is a really important one. We will carry on having conversations around this, and perhaps we need to return to the marker question again. I certainly wouldn't be averse to doing that. Thank you all so much.